So another concept that you'll commonly come across when you're dealing with probability is something called the multiplication rule. Okay, and there's a lot of fancy looking terminology here. You can certainly read that, but here's the main kind of summary of the multiplication rule. This rule is used anytime you have to find the probability of a statement like this. So find the probability, let's say, of picking a king and picking a queen on the next one. Okay, so you have multiple events, and this is the key word. If you ever see the word and means that you're supposed to be multiplying the probabilities. So the probability of event K and event Q means multiply the probability of that times the probability of that. So that'll be clear with an example, which we'll do a couple of right now. Okay, so we'll do this one together, but as always, if you feel inspired to be able to solve this on your own, certainly pause the video and give that a try. So it says 2 cards are selected, so we know we're going to have 2 events, okay, without replacing the first card. That's important, okay, because obviously it's going to that means these are dependent events. If we're not replacing a card, that means we no longer have 52 in the deck. Okay, find the probability of selecting a king, and is what tells us that we're going to be multiplying. That's the key word. Later on we'll talk about the word or. Or does not mean multiply, or means add, but the word and means multiply. So find the probability of picking a king and on the second card picking a queen. So another way of saying this is find the probability of a king times the probability of a queen, given that we picked a king the first time and didn't replace it. That's important. So the probability of picking a king, well, there are 4 kings out of 52 cards, times, and then the probability of picking a queen, well, there's 4 queens, but there's not 52 cards anymore because we took out that king and we didn't replace it. So now there's a 4 in 51 chance. Okay, and you could, usually you'd want to use a calculator for this. This actually simplifies to 1 in 13. And when you multiply that, you get 1 times 4, which is 4. 13 times 51 is, I don't have a calculator in front of me, I think that's 663. So you could either leave it like that, or you could find the decimal version of that. And that's going to be pretty small. I'm guessing it's going to be somewhere similar to like maybe 0.06, something like that. So about a 6% chance of that happening. Okay, and there's one thing I want to mention when we talk about a 6% chance of that happening. You might recall from earlier in the course, anytime there is less than a 5% chance of something happening, that is considered unusual statistically. So you might have a homework problem where they say find the probability and tell whether this is unusual or not. Okay, and actually I misspoke. That example we just did, I think it wasn't 0.06, it was 0.006. The number was 4 out of 663. So again, I don't have a calculator, but I believe it's somewhere around there. And of course, that number is definitely smaller. That's a 0.6% chance. So that would certainly be considered unusual statistically. Okay, picking a king and then a queen is pretty rare. All right, next example, a coin is tossed, and again, and is the magic word that tells us we're going to be multiplying. So the probability of tossing a head, okay, and rolling a 6. That's another way of saying the probability of tossing a head times the probability of picking or rolling a 6. Well, I could say picking a 6 given that we picked a head, but remember we don't need to say that because that's the same thing as just the probability of rolling a 6. Rolling a 6 has nothing to do with flipping heads. Those are 2 independent events. So what's the probability of tossing a head? It's always 50-50, so 1/2. What's the chance of rolling a 6? Well, if you're familiar with a standard 6-sided die, there are 6 faces, and only 1 out of those 6 faces are having the number 6. So 1/2 times 1/6. If you forgot how to multiply fractions, it's those numbers multiplied, and then on the bottom those numbers multiplied. You don't need a common denominator to multiply fractions, only to add them. So the chance is 1/12, and if you find that as a percent, it would be about 8.3%. So not a great chance, but it's not considered unusual. Unusual starts at 5%.